So the definite integral. And the first part is what we call, I'm going to slowly get you to understand Riemann sums. Okay. So the first thing I'm going to show you is sigma notation. Okay, so it's a new notation, which is very important because we're going to use it a lot at the end of the course when we do sequences and series. Okay, so here's how it goes. If I want to say 1 plus 2 plus 3 plus 4 plus 5. Okay, there's a shorter way to write this. Okay, you've probably seen it a bit in physics when you did sum of vectors, you've seen the symbols. We write it like this. Sum, that's a sigma. It's a Greek letter, capital sigma. When, let's say, I goes from 1 until 5 of I. Okay, so this is how to write a shorter way to write this sum. Okay, so how does it work? You plug in 1, I equals 1 into the expression that's here, and that's 1, plus, right? It's like it counts, okay, and it adds. Then it becomes 2, you put a 2 here, plus 2, and then it becomes 3, and so on and so on. It stops at 5. Okay, good.
Wait, so you're saying that it goes, whatever number that's under, it's gonna go from that number to the top, so
Yeah.
1 to 5?
Yeah.
So,
Okay.
okay.
So for example, let me give you an example. That's a notation. Okay. So for example, and then I'm going to show you all the properties of what we could do with this. So for example, let's say evaluate. So 1, let's say the sum I goes from 2 to 4 of I squared plus 2I pairs. Okay, I'm just inventing that. Okay, so I'm just going to put it in brackets here so that you know that it's the whole thing that's being inside the sum. Okay, so I plug in 2 here. So I get what? For my first term, I get 2 squared plus 2 times 2 plus. Then this becomes 3, right? My first, now it started at 2. Here it started at 1, now it starts at 2. So my second term is at 3. So 3 squared plus 2 times 3. And then my third and last term is when it's 4. So it will be 4 squared plus 2 times 4. Okay.
Sir,
Yes?
is this sigma notation as if you're writing like I across this interval, like across these value of x, like these I values are the ones we're using?
Sorry, I didn't understand. These I values are what? What?
Like it's sort of like domain or like interval notation, or like it's telling this sigma is telling you I is equal to these values.
Okay, so you have to be careful because when you're talking about interval notation, you're talking about something that's continuous. So between 2 and 4. Okay, when I heard the words integral, I heard the word interval. So between 2 and 4 means every value between 2 and 4, 2.1, 2.2. But when we're dealing with sigma notation, we're dealing with discrete. It's called discrete, okay, or countable. Okay, in this case, so 2 until 4. So it's really just 2, 3, 4. You count them. They're discrete. They're separate. They're distinct. There's no interval. It's a set of 3 values that we add. Is that okay? Do you understand the difference?
Yes, sir. Yes, sir.
Okay, good. It's a good point to raise. Okay, so let's calculate. Now it's just a calculation. Okay, so it's easy. So 4 plus 4 is 8. 9 plus 6 is 15. And so I have 15 plus 8 is 23. And then 23 plus 16 is 39. 39 plus 8 is 47. So this sum is equal to 47. Okay.
Sir,
Second
do you mind
one.
explaining
Yes.
why 47? What do you mean sum?
Add, do the addition. Calculate this.
But what's the I squared plus 2 times I represent in the first place?
This is the expression that I'm summing.
Okay.
If you plug in I is 2 here, you get a value. If you plug in I is 3, you get a value. If you plug in I is 4, you get a value. 1, 2, 3 values, add them. You understand?
So, and then just the 2 and 4, it just tells us the limitation of what number we have to put in there?
Yeah, exactly.
Okay. Thank
Okay.
you.
Let's do one more until you're comfortable with this. I equals, so let's say 0 until, let's say 4 of 2 power I plus 1. Here's 1. Okay, so let's plug in 0. So it's 2 power 0 plus 1 plus 2 power 1. Plus 1 plus 2 power 2 plus 1 plus 2 power 3 plus 1 and then plus 2 power 4 plus 1, and I have to calculate this. So 16 and 8 is 24, 24 and 4 is 28, and 2 is 30, and 1 is 31, 32, 33, 34, 35, 36. This sum equals to 36. Algebraic properties. So this is what I can do with sigma notation. So first thing is I have this, if I have the sum I equals anything until n, okay, of let's say at certain terms ai plus bi, a sum of two expressions. Okay, so this, I could do the sum of the first plus the sum of the second. So it's equal to the sum of ai plus the sum of bi. Okay, so basically I could evaluate each term and then add them, or I could just find the sum of these terms plus the sum of these terms. Same, it'll be the same answer. Same thing if this was a minus.
How does I equals 1 equals anything?
How does, sorry, how does I what?
You said that I equals anything.
I takes on every values from 1 to n.
Oh, okay, okay.
Okay. The second property, there's only two. It's the sum I equals 1 until n of, let's say, a constant k times ai. Okay, so I could pull out the constant out of the sum. K times sum I equals 1 until n of ai. Okay, we're going to do an example for this in a second. These are called, you know what we call these properties? called linear properties.
Sir, aren't these present basically everywhere?
These properties,
Yeah, because you notice them in limits, notice in integrals.
yeah, they're present for limits, for integrals, for derivatives, absolutely. Okay? You're going to see why they're present for integral, because you're going to realize very soon that an integral is actually a sum. Okay? But slowly I'm going to make the connection. Okay? But when you're going to do linear algebra, okay, your last math course, you will understand much better what linear means. Okay? But that's the basic of what linear means exactly. These are these properties. Okay, so for example here, let's do the sum I equals 1 until 1 until, let's say, 3, okay, of I don't know, 2i plus I squared. Okay, so we could do it two ways. One, we could find all three terms. So it's sum. So I plug in 1 here. So 2 times 1 plus 1 squared. Then I plug in 2. 2 times 2 plus 2 squared. And then I plug in 3. 2 times 3 plus 3 squared. And then I stop because it stops at 3. And I calculate this. And so I get 2, 3. This is 4 and 4 is 8. So 8 and 3 is 11. And 11 and 9 is 20, 26 I get. Okay, that's one way to do it. And the other way, yes?
I have a question.
Yeah.
Can you explain the second one? So it's just a constant times a times 1?
Yeah, you're
times
going to
I?
see it now in the example. Here,
Okay.
I could do it. Since it's a sum of 2, right? It's a sum. I could do the sum of each one. Okay, so it's equal to sum of 2i plus sum of i2. I equals 1 until 3. I equals 1 until 3. Okay, so that's the first rule, allows me to do this. And the second rule allows me, that's your question, to pull out the 2 here. So it's sum I equals, can you still see at the bottom, or it's too low?
No, we could see.
Okay, 2i plus and sum I equals 1 until 3 of I. Okay, and now let's expand this. So it's 2 times, that's an I2. So it's 2 times this sum. So 1 plus 2 plus 3 plus this sum, which is 1 squared plus 2 squared plus 3 squared. Okay, that's the other way to evaluate it. So this is 6 times 2 is 12, and 9, 13, 14, and 14 and 12 is 26. Perfect. You see, both ways, same thing.